Hello, my name is Bradley Wilkerson. So up here we have the picture of question one. So question one wanted us to make basically what's going on with replication, of DNA replication. So here we have our main DNA, our parent DNA, and we have the helicase that splits that DNA. And as that DNA splits, then we have over here the primer that is made by a DNA primase over here. And then once we have that primer down, we can have the polymerase 3 attached to that and start moving down the, oh, I mixed these up. So this is the 3 end, that's 5, and this is 3, and this is 5. And then this side is 5 prime and then 3 prime. There you go. And so the polymerase 3, it moves down from 3 to 5. And it just goes continuously. Whereas on this side, the lagging side, we have multiple DNA primases building multiple primers, and the polymerase are able to attach those primers and work in the opposite direction. These multiple different sections are all called the Okazaki fragments. And then up here we have the ORIC, or the origin of replication, and that's where it all starts. And on the right side of the ORIC, it looks like this, but on the left side, these strands flip, or they don't flip, but the leading strand is now on the bottom, and the lagging strand would be now on the top. And so you'd have this polymerase going that way, and then the Okazaki fragments would be up here on the top. And that's question one.
Yeah. Wait. Yeah. Yeah.
You probably just hold it.
Yeah. That's.
Oh.
Jeez. Thanks. Just gonna hold it. Okay. Hi, I'm Donovan Wixom. I'm doing. Yep.
Continuous?
Yep.
Are you serious?
Yeah. I'm doing question 2. Okay, so part A, DNA primase is the protein complex synthesizing primers in eukaryotes. DNA A is the protein that promotes the separation of the AT-rich sequences within the ORIC. Epsilon is the subunit of polymerase 3 that proofreads the activities. DNA polymerase alpha is the protein that synthesizes the leading strand in eukaryotes. TUS, or the termination utilization substance, is the protein that that displaces DNA polymerase 3 from the chromosome to terminate replication. DNA polymerase 1 is the protein that has 5' to 3' polymerase and 5' to 3' exonuclease activities. Topoisomerase 2 is the protein that introduces negative supercoiling into the DNA ahead of the replication fork. And the ORIC, or the origin recognition complex, this protein binds directly to the ARS element. The single-stranded binding proteins are the proteins that prevent DNA strands from annealing during replication. And finally, DNA ligase is the enzyme that seals Okazaki fragments into a continuous strand of DNA. Thank you. Hi, I'm Tyler. I'm doing number 3. So, let's see. I can read the question here. All right, so we already explained what a lot of the enzymes do. Number 3, though, it asks, so this question concerns the enzymes involved in DNA replication. So part A lists the 5 enzymes, either prokaryotic or eukaryotic, that consume ATP during DNA replication. And we got DNA A, DNA helicase, gyrase, primase, and ligase.
So part B, the 5 enzymes that consume DATP during DNA replication is DNA polymerase 1, polymerase 3, delta, epsilon, and polymerase 2. Part C is the same answers as in part B. And these are the ones that have 3 to 5 prime exonuclease activity. Part D is, so we have to indicate one enzyme involved in replication that uses DNA as a template to synthesize RNA, and that's DNA primase. And then the last one, part E, an enzyme that uses RNA as a template to synthesize DNA is telomerase.
So I'm Christina Cross, and I'm going to be doing number 4. And she goes over in her video, so I'm just going to be listing all the letters, like rephrasing them, I guess. For A, we got 5 prime, then A, C, T, G, A, T, G, G, T, C, C, T, G, C, T, A, T, and then 3 prime. Should I just write it down, guys?
Yeah.
Yeah. Okay.
At least the first one.
Yeah, After that, you can just kind of mark on the first one.
Okay, you guys, I'm sorry. I'm just so tired and disabled. Okay. Yeah, my handwriting's gonna be really bad because I hurt my arms, so A T G G T C C T G C so bad. A T 3 prime N. Sorry. 5 prime N. That's A. And then for B, it's just gonna be it can do all of them except for the C because it's a D. It's DCMP instead of DCTP. So it's just gonna be 5 prime. And then an A. And it's gonna stop because it doesn't know what to do. It doesn't have the right stuff to continue making it. For C, it's everything but T because it's GTP instead of DGTP, DTTP. And so it's going to be AC 3 prime. Then for D, it's everything but G because, again, it doesn't have the right stuff. GTP instead of DGTP. So it's 5 prime ACT 3 prime. Yay.
I'm Hadley Pinder, and I'm doing problem 5. Just asking what proteins are found in certain parts of the replication. And so for part A, it says, which of the proteins above is found in the prokaryotes? So out of just the ones that are above, it's DNA gyrase, the TUS, DNA A, DNA primase, DNA polymerase 1 and 3 with the alpha subunit. And then for B, it says, which of the above proteins is found in the mouse? It's the CDC6, DNA polymerase epsilon, DNA polymerase alpha, telomerase, MCM helicase, PCNA, and DNA primase. And then for which of the above proteins is involved in chromosome compaction? We decided that there wasn't really any that were involved in the actual compaction of the chromosome, but that DNA gyrase maintains like the certain level of compaction in the chromosomes. And then D, we said which of the above proteins is involved in the initiation stage of DNA replication? And we said it was CDC6, DNA A, MCM helicase. And which of the following were involved in the termination stage? And because eukaryotes don't have any, it's just the prokaryote ones, which is TUS and DNA gyrase.